Integrals are very picky. If we want to integrate something, we have to make it match a formula very exactly. For instance, if an integral is in this form, we know it evaluates to this. But, like a wrench thrown in the machine, if you add even a single extra thing not accounted for in the formula, the whole formula doesn't work. The only exceptions to this are multiplication by a constant, which can be brought out no problem, and adding extra terms, since you can integrate those separately. So, if it doesn't match an integral we know, we have to change it until it does, and we have some strategies for that. One method is just straight up simplification and rewriting. That one's pretty familiar. Another method you're probably familiar with is U substitution. Something interesting about U substitution is that it's just the chain rule, but in reverse. The chain rule requires you to pull out the derivative of the inside part of a function. And U substitution is just the process of identifying that inside part and sort of packing it back up. Integration by parts is another one of these methods for rewriting integrals. And it's even the reverse of another derivative rule, specifically the product rule. The product rule allows us to take derivatives of products of familiar functions by using this formula. While we usually use letters F and G when talking about the product rule, let's change those to U and V for a minute. Additionally, let's write the derivatives of U and V as du and dv instead. Then, let's solve this equation for u dv. Finally, integrate both sides and simplify a little bit. What we're left with is the formula for integration by parts. The integral of u dv is equal to uv minus the integral of v du. This formula allows us to rewrite integrals of the product of two things, which might just allow us to evaluate them. Most of the time, we'll have to identify u and dv ourselves, so it's a good idea to keep in mind what we need from those factors, so we can identify them more easily. For instance, notice that you'll need to take the derivative of u to find du, and the integral of dv to find v, since both of those appear on the right side of the equation. So, make sure the factor you choose for dv is integrable. Additionally, you can look out for any factors that turn into something nicer when you take their derivative, like polynomials. Those make good candidates for u. Let's try to use integration by parts on this integral. Firstly, I noticed that integrating the natural log of x is a lot harder than taking its derivative, so I want to try making that u first. That means the other factor, x, is dv, which is fine because I can integrate that pretty easily. Once we have all four parts, we can rewrite our integral using the integration by parts formula. Notice that, with a little bit of simplification, we can actually evaluate that integral. So let's do that and end up with our answer. Now, I could end the video here, but there's one other thing about integration by parts that I think is at least worth mentioning. Sometimes we do something with integration by parts that's not exactly obvious, but it's very useful. To show you what I mean, let's try to evaluate this integral. I don't see any big reason to pick one factor over the other for u and dv, so let's just pick one. When we rewrite our integral using integration by parts, we're left with a very similar integral with similar problems. But, being as stubborn as I am, I'm just going to try it again. Maybe it'll work this time. Every time you use integration by parts, remember that you're just replacing a single integral. So be careful with things like parentheses and multiplication. Wait, this isn't any better. In fact, it looks like we're right back to where we started. However, we can use that. Remember, we've just been rewriting this integral from the beginning. So we can set our function now just equal to it. Because it is. If we move both of our identical integrals to one side, we can see that, since they're the same, we can combine them. Like adding x and x to make 2x. It's weird, but it works here. Make sure to leave a c behind, for good measure. Then, divide both sides by that too, and you've solved for the integral. Now, I know that this kind of feels like cheating, because at no point did we actually evaluate an integral. But it absolutely works. You can test it, take its derivative. You should end up with the thing inside the integral. And that's pretty much everything you'll need to know about integration by parts. Give it a shot yourself. Thanks for watching. Bye!